Hello everyone. In today's class, we'll discuss about the design of fillet weld subjected to axial load. And in that, the first case to be considered is symmetrical case. When the weld is applied symmetrical to the plate, symmetrical means whatever the weld is being applied, it is a mirror image of the other side. So when the weld carrying equally the load, what is the procedure of designing the fillet weld? So fillet weld, as we know, generally which it will be applied for the lap joint. Here the figure shown, this figure, which is, this is a plate. On this plate another plate is kept like this, just a plate, and the load is being applying in this direction, and whatever the load is been applying, it is to be carried by these two sides of the weld, and these two welds are symmetrical to each other. So in that case, so what is the design procedure we will discuss in this in these steps. Okay, so the first step to be followed is, so assume a suitable size of the weld. The weld size to be assumed suitably, and you have to refer table number 21, page number 78, IS 800 2007, where the minimum size of the weld and maximum size of the welds are been given. What is the minimum size of weld to be taken for a fillet weld, and what is the maximum size you need to apply for the uh, plate, and that maximum size is depending upon the uh, edge conditions. If it is a square edge, what is the thickness to be providing? If it is round edges, what is the thickness to be providing? So there, here I have shown minimum size. You have to refer table number 21, page number 78, IS 800 2007, and maximum size 1.5 mm less than the thickness for square edges. Means here I have shown one figure, this figure. In this figure, two plates are being joining, that is by keeping one plate above the other, and this edge, suppose uh, say this is one plate and another plate is kept like this, and here we need to apply the weld, but this corner, what you call this square corner, square edge, square corner, and if it is forming a square corner, a square edge, you need to deduct 1.5 mm from the thickness of the plate. So this 1.5 mm to be deducted from the thickness of the plate, and whatever the left thickness, that much to be applied for the plate. That is a maximum size to be applied, and minimum size and all it is given in a table 21 depending upon the thickness of the plate. Here I'll show you. uh, this is a table number 21, minimum size of first run or of a single run fillet weld. So here they are mentioned thickness of thicker plate, thicker part, and minimum size. Here over, up to and including. In first one, up to 10 mm plate thickness, the minimum size to be providing 3 mm, 3 mm, and 10 to 20 mm thickness of plate are to be joining, the minimum thickness to be providing is 5 mm, and 20 to 32 mm thickness of plate are to be joining, the minimum thickness to be providing is 6 mm, not less than that, and 30 to 58 of first 8 mm to be providing first run, and next run 10 mm for a minimum size of weld. So these are to be given here, and maximum size, it depends upon the edge formation. So here it is given, in this case, this one, this is forming a square edge here. In this square edge, suppose this thickness is T, and while applying the weld, in this thickness you have to deduct 1.5 mm. It is for square edges. And for a round corner, suppose this is a round corner here. This is a round corner, a round edge. That is when this is one plate, when the angle is like this, if it is forming a round edges like this, then for this round edge, the thickness of weld to be providing by deducting 1/4 of thickness of plate, or the thickness of weld to be providing is 3/4, 3/4 thickness. Okay, so these are the specifications given in a code. It depends upon the edge conditions, the maximum size of weld to be applied, and also the minimum sizes of welds are being given. So please refer IS 800/2007, page number 79 on table number 21. You please refer here the thickness, that is a minimum size, and the maximum sizes are being given. So according to that you have to apply the thickness. So here, as I mentioned in step 1, you have to assume suitable size of the weld, that is a minimum size and maximum size depending upon the edge conditions. Then after getting a thickness, so you have to calculate the effective throat thickness. And effective throat thickness for a fillet weld, generally the weld applied is assumed to be, it is at an angle of 45 degree. So for 45 degree, the value of K will be 0.7 and 0.7 times of S. Okay. Then after this, in step number 2, once we calculate thickness of weld, in step number 2 we have to calculate strength per millimeter run, that is strength of weld for 1 millimeter length, that is called unit strength of weld, that is PUW. So here PUW, this one PUW, where P indicates the strength, U indicates the unit, and W indicates the weld, that is unit strength of weld. That is for 1 millimeter run, what is the strength of weld, that is to be calculated first. So after this, here the unit strength of weld, as we know the stress equal to load by area, that is the stress is force by area. I need a force, that is the strength of weld, stress multiplied by area. So area here means area of the weld multiplied by the stress in the weld, design stress in weld. So area to be calculating based on the length of the weld multiplied by thickness. We know the thickness, effective throat thickness, calculated in step number 1, and the length of weld to be calculating based on how much length of weld to be applying for the plate, and design stress of weld will be Fu divided by gamma 3, Fu divided by root 3 into gamma mw, and gamma mw represents partial safety factor for weld, that depends upon the site weld as well as the shop weld. Since we are calculating strength per millimeter run, so here the length of weld will be the 1 mm. For 1 mm length, what is the strength of weld we are calculating, and T represents the effective throat thickness, and this term represents the stress in the weld. If you substitute all things here, we get the strength of weld per millimeter run. So after calculating strength of weld per millimeter run, then we have to calculate what is the design strength of member gross. So gross strength of member, so that is a PU, or ultimate load carrying by the member, that is TDZ to be calculating. It is given in a clause number 6.2 IS 800 2007, page number 32. In case where uh, the load carrying capacity of the member is not given, in that case we have to calculate by using this formula. This formula we have to use to calculate what is the load carrying capacity of the member, that is a TDZ, design strength of member in gross, that is AZ multiplied by Fy divided by gamma MO, where AZ represents gross area of the member, Fy is the yield stress of the member, and gamma MO is the partial safety factor for the plate material. Once we get that is the design strength of the member or the ultimate load carrying capacity of the member, then we can easily get how much length of weld to be applied, because we know the strength of weld per millimeter run, and also we know the strength of or ultimate strength of the member. Then if we divide for the sorry, that is here it is given the length of weld, uh, here this one, the length of weld will be ultimate load carrying capacity of the member divided by unit strength of the weld, that is 1 millimeter length of weld. What is the strength? If we divide this one, we get how much length of weld to be applied for carrying the given load, and that uh, length of weld we can equally uh, divide like this. This is the member. Then finally we have to apply the weld. This is the load carrying by the member PU, and for this PU whatever the length of weld we are getting, total length, that is to be dividing like L1 plus L2 you have to apply on the both side. This is LW1, this is LW2, which is applying symmetrically, because this is the axial load carrying by the member and the load is distributing equally. This is PU and this is a PU1 and this side is PU2. I'll show you once again. I'll zoom it. Suppose this is the member carrying the load PU, and this, since it is a symmetrical, is acting at the center symmetrical, the load carrying by this side of weld and the load carrying by this side of weld, this side of weld is the load carrying by this side of weld will be PU by 2. So the load carrying by this side of weld and this side of weld, this side of weld is this side PU by 2, PU by 2, and this side PU by 2. For that LW1, LW2 we get. That is the design of weld. This is for symmetrical case.